Today also we'll solve some more numericals on DIF FFT algorithm. Right. So last numerical on DIF FFT algorithm. So find the 4 point circular convolution of x of n and h of n given in figure A and B using radix to DIF FFT algorithm. DIF FFT algorithm. Here x of n and h of n is given. So x of n is a discrete signal. So having only the 4 values with magnitude of 1. 0, 1, 2, 3. This is figure A. So this is the x of n, and one more is h of n. So here it is 1, 0, 1, 0. So this is figure 2. Figure B. This is the given the problem statement. So x of n and h of n is given. So we have to find the 4-point circular convolution. Alright. So how to find that? We know y of n is equal to x of n 4-point circular convolution of h of n. Right. So we have to find the DFT. So for that we have to use the IFFT of x of k into h of k. So first we have to find the x of k using DIF FFT algorithm. First x of n and h of n is given. So we have to find first x of k using DIF FFT algorithm. Similarly, h of k using DIF FFT algorithm, multiply it, and whatever the answer we will get y of k, for that you have to apply the DIF FFT algorithm. Right. So first we will take the first signal x of n. So x of n is nothing but it is 1, 1, 1 and 1. 4 values are there. So we have to take the 4-point DIF FFT, right? So I will write x1 of 0, or else x of 0, x of 1, x of 2, and last one is x of 3. So values are 1, 1, 1, 1. Take the butterfly diagram. First one is 4 point. After that 8 point. So 4 point. Draw the butterfly diagram. So first two are 1, 1, then next two are -1, -1, up arrow, down arrow. Compute the values, and whatever the answer we'll get here, so we have to multiply with the twiddle factors. So what are the twiddle factors? So here W4 of 0 is 1, and here W4 of 1 is minus j, because cos 90 minus j sin 90, cos 90 is 0, sin 90 is 1, right? So minus j into 1, so minus j. So W4 of 1 is minus j. Compute the values. Here 1 plus 1, because here summation is there. So 1 plus 1. So 1 plus 1 we'll get here 2. Compute here. So here it is 1, and one more is from here. So 1 into 1, 1 plus 1, here also we will get 2. Calculate the next value. What is the value here? 1. So what is the value here? 1 into minus 1. See here, what is the value here we'll get? So from here it is 1, and here 1 into minus 1. 1 into minus 1 is 0. 0 into 1 we'll get 0, right? So here it is 0. See here once again, 1 into minus 1. 1 into minus 1 is minus 1. So 1 minus 1 we'll get 0. 0 into the twiddle factor 1. So we'll get 0. Calculate the last value. What is the value here? So this 1 is connected this point. So 1. So 1 into minus 1. 1 into minus 1 is 0. 0 multiplied with the twiddle factor. So again here we'll get 0. Take the next 2 point. Take the 2 point butterfly diagram. So here it is 1, minus 1, 1, minus 1. Compute the values. Here twiddle factor is W2 of 0. What is W2 of 0 is 1. So here it is also the twiddle factor, it is 1. Compute the values. 2 into 1, 2. 2 and here addition is there. This 2 plus this 2, here we'll get 4. And next here it is 2, because this 2 is connected here. 2 into minus 1, minus 2. So minus 2. 2 minus 2 is 0. 0 into 1 we'll get 0. See here 2 into minus 1, minus 2. 2 minus 2 is 0. 0 into the twiddle factor, again we'll get 0. See here the next one, 0 into 1, 0. 0 into 1, 0. So here it is also we'll get 0, 0. Right? So if I write, so k here and x of k. So what is the values here? 0, 2, 1, 3. Arrange the sequence. So 0, 1, 2, 3. When x equal to 0, when k equal to 0, value is 4. When k equal to 1, the value is 0. When k equal to 2, again it is 0. And 3, this is the 0. So x of k we have calculated. Similarly, calculate h of k. H of k. What is the h of n is there? So h of n is nothing but, what is h of n? 1, 0, 1, 0. See here. 1, 0, 1, 0. 1 0 1 0 1 0 1 0. Compute h of k, h of k. So I will write h of 0, h of 0, h of 0, h of 1, h of 2, h of 3. Write the values 1 0 1 0 1 0 1 0. After that, apply 4-point butterfly diagram. Draw the 4-point butterfly diagram. So connected to third point, connected to fourth point. So first point, second point. So two up arrows, two down arrows. So first two are positive 1, the next two are -1. Compute the values now. Uh, 1 into 1, 1. So this value, right, this point is connected from here. So 1 plus 1 will get 2. The next one, 0 into 1, 0 and 0. So here we'll get 0. The next one, it is connected from here. So here it is 1. 1 into -1. 1 into -1 is -1. So we'll get 0. Even though if you multiply with that middle factor, we'll get 0. So here 0, 0. 0 plus 0 is 0. 0 into -j is again we'll get 0. So this is the first stage answer. Similarly, solve it for 2 point. 2 point. So 2 point. Write the twiddle factors. W2 of 0 is equal to 1. W2 of 0 is equal to 1. Here the arrows also you have to show it. Compute the values. 2 into 1, 2 into 1, 2. Again this 0 is added here. So 2 plus 0 will get 2. So 2 minus 0 into 1. So here it is also will get 2. The next one, 0 into 1, 0 plus 0 will get 0 only. 0 plus 0, here it is also 0. So here it is 2. 2 plus 0 is 2. Apply the 2 to 0 0. Write it in the sequence. Here it is 0 to 1 3. 0 to 1 3. Write the sequence k, h of k, h of k. K is 0 1 2 3. When k equal to 0, what is the value? H of k is 2. When k equal to 1, what is h of k? 0. When k equal to 2, what is the value? 2. And last one is 0. So now we have computed x of k and h of k, right? So multiply h of k and y of k is equal to multiply x of k and h of k, x of k and h of k. So that is nothing but 4 0 0 0 multiply with 2 0 2 0, we'll get 8 0 0 0, 8 0 0 0 we'll get. So now for this is nothing but y of k. This is the nothing but y of k. For this y of k, right? So we have to find the DFT, right? So this is there. So we have to apply the inverse fast Fourier transformation. IFFT is nothing but inverse fast Fourier transformation. We have to find y of n. So if I want to find y of n, so again one more time we have to apply the DIF FFT algorithm for the y of k. So write those values. 8. So I will write 8, 0, 0, 0. So write the values. Take the here 2 down arrows, 2 up arrows. Show the direction. Here it is 1. Here it is also 1. Minus 1. Minus 1. Total factors. W4 of 0 is 1. W4 of 1 is minus j. Minus j. Compute the values. Compute the values. What we'll get here? So obviously 8 plus 0 will get 8. So 1 plus 0 plus 0, 0 will get here. See at this point 8 plus 0. 8 into 0 into minus 1 is 0 only and multiplied with 1. So here we'll get 8. See here 8. 0 into minus 1 is 0. So 8 plus 0 is 8. 8 into 1, 8. So the next one here 0 plus 0 will get 0. The next one, take the 2 point DFT. Compute the write the twiddle factors also. So W2 of 0 is equal to 1. W2 of 0 is equal to 1. Compute the values. Compute the values. So 8 plus 0 will get 8. So 8, 0 into minus 1 into 1. So we'll get 8 only here also. Here 8 plus 0. Here it is also 8 plus 0. So all will get 8, 8, 8 values, right? So now if I want to write, so y of n is nothing but, so 4 point is there, right? So 1 divided by 4 point DFT is there. So 8, 8, 8, 8. So if I write y of n is equal to 8 by 4, it is nothing but 2, 2 and 2. This is the final answer. Just see that. The x of n, see here once again, the x of n and h of n is given. So we have to find the 4-point circular convolution using DIF FFT algorithm. So if I want to apply the DIF FFT algorithm, obviously we have to find the x of k and h of k. Once you find it, multiply it, and whatever the answer is there, the answer is also in terms of y of k. For that you have to apply the once again DIF FFT algorithm. And whatever the answer is there, so once you are computed, so we will get y of n, that is nothing but 4-point circular convolution. See here, this is the given problem statement is there. So first I have computed the x of k, and similarly using DIF FFT algorithm, so computed h of k, so multiplied x of k and h of k, we'll get 8000. So once you again apply the DIF FFT algorithm, we'll get 8888. So 1 divided by n, because this is the 4 point. So once you take the 1 by 4, that is nothing but 1 by n. So we'll get 2222 as the final answer. So in the regular lab, we have written the code for the overlap add method, overlap save method. We have discussed the program part, how to find the overlap add method, overlap save method using MATLAB, and the procedure also briefly discussed in the lab session. So we'll solve one numerical on overlap add method, one numerical on overlap save method. The already theory part is discussed in the regular lab session, right? Only we'll give the steps here. So just recall the steps. Take the problem, perform the x of n multiplied with h of n, where n is varying from 0 to 11, for the sequence x of n and h of n given below, using overlap add method, overlap add method. So in this problem statement, x of n and h of n is given. The h of n is nothing but 1 1 1, and the x of n is nothing but take the values 1 2 0 minus 3 4 2 minus 1 1 minus 2 3 2 1 minus 3. So 4 plus 4 8 12 13 values are there. So if I want to apply overlap add method and overlap save method, we know that some formulas. What is that? So the L is nothing but the length is equal to 2 raised to m. M is nothing but number of values are there in the h of n. So how many values are there? So 1 2 3. So m equal to 3. M is nothing but, so here 3 values are there. So because of that, m is equal to 3. So the L is nothing but 2 raised to 3, we'll get 8. L is equal to 8. So means we have to use total 8 values while performing the overlap add method. So at a time we have to use 8 values, right? So, and out of 8 values, how many values we have to choose from the x of n? So for that also we have to find the n. So for that, one more equation we have, L is equal to M plus N minus 1. L is equal to M plus N minus 1. We know the M, we know the L, M, we have to find N value. So N is equal to L minus M plus 1. So L is 8, M is 3 plus 1. So 9 plus 8 plus 1, 9, 9 minus 3, 6. So N is equal to 6. Means out of 8 values, 6 values we have to choose it from the X of N. Right? So out of the 8 values, 6 values we have to choose it from the X of N at a time. Write the equation here. X1 of N I will write. X1 of N. So 6 values I will take it. The first 6 values. So 1, 2, 3, 4, 5, 6. The first lot I will take it. So 1, 2, 0, minus 3, 4, 2, and last 2 values we have to choose it as a 0, 0. Remember, in the overlap add method, so we are adding 2 zeros at the end to make it n equal to 8. So I will write h1 of n also. So h1 of n is also, the length is again 8. The first 4 values are no, first 3 values as it is we have to take it from here. So the length is 8. Already 3 values are there. So 8 minus 3, so is equal to 5. So 5 zeros we have to consider. 5 zeros we have to consider. So write it in the equation form. So y1 of n is equal to, so x1 of k plus h1 of k. h1 of k. I will write this one in terms of equation 1 plus 2. So 0, 1, 2, 3, 4, 5. Remember this one, right? So 1 into W8 of 0. W8 of 0 is obviously it is 1. Here k value, right? So here W8 of k, because 1 is there, n equal to 1. So I will write 1k. Here 0 is there, ignore it. Minus 3. W8 of, what is the value, n value? 3. So 3k plus 4. W8 of, what is the value here? 4. So 4k plus 2. W8 of 5k. W8 of 5k. So this is the x of k. Multiplying with h of k. H of k is nothing but, so here it is 0, 1, 2. Only the 3 values are there. So I will use 1 plus W8 of k plus W8 of 2k. W8 of 2k. Multiply the values and simplify it. Multiply the values. So 1 into 1. I will multiply 1 with this matrix, this entire equation. So 1 plus 2 W8 of k minus 3 W8 of 3k plus 4 W8 of 4k plus 2W8 of 5k. So 1 is multiplied with the entire equation. Now W8 of k you have to multiply with this equation. So 1 into W8 of k. So we'll get W8 of k plus 2 W8 of k into W8 of k. So that is nothing but W8 of 2k. Remember, it is the addition of the orders. So k plus k, 2k plus minus W8 of 3k plus k, 4k. So minus 3 W8 of 4k plus 4 W8 of 4k plus k, 5k. K plus k, 6k. The next, this value is multiplied with the entire equation. Last step, multiply and so compute the values. So 1 W8 of 2k. Make the addition here. Whatever the values are there, same values, because here the value is 1. So multiply. Just here the whatever the order is there, make it plus 1. So 2 W8 of 3k minus 3 W8 of 5k plus 4 W8 of 6k plus 2 W8 of 7k. Make the addition now. So here 1, 2 plus 1, 3 W8 of k. So plus 3 W8 of k. Next, 2 plus 1. Whatever the order 2k is there, so we have to calculate. So here the value is not there. 2k plus 1k. So 3k. Right? So that is nothing but 3 W8 of 2k. So now this is cancelled, this is cancelled. Now minus 3 plus 2. Minus 3 plus 2 is minus 1. Minus 1 W8 of 3k. W8 of 3k. Next, this is cancelled, this is also cancelled. So 4 minus 3 plus W8 of 4k. So this is also cancelled, this is also cancelled. Now 5k. 4 plus 2, 6. 6 minus 3. So we'll get plus 3. 3 W8 of 5k. So this is cancelled, this is cancelled, this is cancelled. 6k. Right? So yeah. 2 plus 4, 6 plus 6 W8 of 6k plus 2 W8 of 7k. Right? So this is the y1 of n. y1 of n. y1 of n. Similarly, find the y2 of n. y2 of n. So see here, now I will write x2 of n. The x2 of n is nothing but the next plot, 6 values. So 1, 2, 3, 4, 5, 6. This is the second slot. What are those values? Minus 1, 1, minus 2, 3, 2, 1. -1, 1, -2, 3, 2, 1. And these are the 6 values, and the length is 8. So the last 2 values we have to consider it as a 0, 0. Right? The same thing, H2 of n. The H2 of n will be remain same. That is nothing but 1, 1, 1, 0, 0, 0, 0, 0. The next of 5 values are zeros. Write the equation x2 of k. X2 of k. No, I will write y1 y2 of n is equal to x2 of k multiplied with the h2 of k. Write those equation. -1 plus 0, 1, 2, 3, 4, 5. W8 of k plus minus 2 W8 of 2k plus 3 W8 of 3k plus 2 W8 of 4k plus W8 of 5k. Is it clear? So this is nothing but x of k. H of k is remains same. That is nothing but 1 plus W8 of k plus W8 of 2k. The H2 of k will be remain same. Compute the values. Compute the values. Compute the values. I will write directly y2 of n. Compute the values. Just check it. I will write directly the values. Right, these values 1, 3, 3, -1 is there. So like that I will write. So -1, 0, -2, 2, 3, 6, 3, 1. So these are the values. This is the values. Now y1 of n you know, y2 of n also you know, right? So y1 of n also you know, y2 of n also you know. I will write here. So n is equal to 0, 1, 2, 3, 4, 5, 6. Around 13 points are there. So n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, like that. So I will write these values 1, 3, 1, 3, 3. So I will write here y1 of n. So y1 of n, what is n equal to 0? It is 1, 3, 3, -1, 1, 3, 3, -1, 1, 3, 6, 2. 1, 3, 6, 2. This is only for reference. Alright. So 6 values we have taken. Beginning, the 6 values we have taken. The next 6 values are taken in the second slot. Right. So I will write this value, whatever the y2 of n is there now. So first 6 values we have taken 1, 2, 3, 4, 5, 6. So from here onwards I will write -1, 0, -2, +2, 3, 6, 3, 1. Make the addition. Make the addition of these two signals. So here nothing is there, means you have to consider 0, 0, 0. I will erase it. So write the values. So this is nothing but y2 of n. Y2 of n. So y of n is equal to, I will write, so 1, 3, 3, -1, 1, 3. Here 6 minus 1 is 5, 2 plus 0 is 2, -2, +2, 3, 6, 3, 1. This is the final answer, y of n. This is the final answer. See here, we have to find the y of n. The problem statement is given, the x of n and h of n is given. The x of n and h of n is given. The x of n is, I have given 1, 2, 0, -3, 4, 2. So 13 values are given. And here h of n is 1, 1, 1 is given. Alright. So first step is we have to follow the steps. We have to add the zeros in the overlap add method at the end. So how many zeros we have to add? So that will be calculated by using this equation. So length is equal to 2 raised to m. M is nothing but the number of values there in the h of n. So in the given problem statement, 3 values are there, right? So that time m equal to 3. So 2 raised to 3 is 8. So the length of the sequence we have to use, it is 8. So again we have one more formula, L is equal to m plus n minus 1. So each step, how many values we have to take it from x of n? How many values we have to consider from x of n? So for that we have to use this equation, L equal to m plus n minus 1. So use the values. So we will get n equal to 6. So means 6 values at a time, we have to use 6 values from the given sequence. So here out of 13 values, first 6 values I have taken for the calculation, right? So total the length is 8, but I have taken 6 values. The next 2 values are there, so obviously we have to use it as a 0, 0. And here for the h of n, only the 3 values are there, but we have to maintain n equal to 8. So because of that, I have taken next 5 values are 0. Make the multiplication. So we will get this equation, right? Similarly, for the calculation, the second slot, because few more values are there, so because of that, again the next slot I have taken. So from -1 to +1. So again 6 values I have taken. The next 2 values are zeros. H2 of n is also there. Just you have to multiply. We will get so this sequence. After that, just you have to make the addition. So if you make the addition, we will get the final answer, right? So you can verify the answer, right? So just to make the cross multiplication and you can verify. So we'll discuss that one in the next class. So in the tomorrow class, we'll solve one numerical on overlap method and how to cross check the final answer. Is it correct or wrong? Right? We'll discuss it in the next class.